Hello, hi to everyone. Uh, it's an engineering channel and engineering and project management channel on YouTube. So, in the last lecture, we covered the project management, project life cycle, and road construction. Today, we have to do the canal construction, and I hope you guys will be with me. So try to subscribe, and if sometime you have difficulty, so there is a in the setting. There is a you can translate on YouTube and Google to your own language. There are many language options. So here is what is project. Project is an endeavor to achieve objective, deliverable. It's called project. It's unique. Uh, Projects is different from one, and then it's not the same. So there will be a is different, and it says a start and end date. It says a fixed duration. So this is project life cycle: initiation, planning, performing, and closing. This also called execution. Execute mean to do some start working. So initiation, planning, performing, and closing. In this stage, we do monitor and control. So what we monitor budget, schedule, quality, communication, and risk response plan. So this is the project life cycle. Today we're gonna do the irrigation canal construction in northern Ontario. The length is 6 kilometer and overall width is 33 feet. 32.8, 33 feet. So when you convert 6 kilometer to feet, so 19680 feet, 1 meter is equal to 3.28 feet. Google it or search it. And this is the top view and this is the front view. Oh, yesterday when if you follow the channel, so we did a project, road construction project, which is 25 minutes. So there is a little bit correction. We did this roads construction, if you guys remember. So it's 5 kilometer road in northern Ontario. So this is 10 meter. For some reason, there is in the lecture, in the video, it's kilometer, but this is meter, 10 meter. So the width is 10 meter. Here is also the feet is okay, 32.8 feet or 33 feet, but this is little bit correction. And so sometime maybe if you are going and learning, so this is the 10 meter width. 10 meter is equal to 33 feet or 32.8 feet. This is correct. It's a 5 kilometer. So this is a reminder and correction in the last section little bit. There is a 3D in the at the end of the video. That's okay, but this is only a little bit correction. So the length is 1968 feet, height is 6 feet, W1 23 feet. W1 is this one, the base. So the canal is usually like this. So when we are calculating the total area of this, so we took this 33 feet, and this also 33 feet. So this is a triangle. So in the other way, if you put this triangle like this and the other one like this, so 23 feet minus is 10 feet remains. So it's mean like it's 5 feet either side. So 5 feet when you minus, so it's cost 28 feet. So the total you can calculate 28 feet. So this is a canal. We're gonna do it in the project. So the name is 6 kilometer irrigation canal in northern Ontario. Future benefit to be used for the purpose of irrigation in area. Scope: all the work done to construct 6 kilometer irrigation canal in northern Ontario. This is the objective. Scope: we further divide WBS. So what is work breakdown structure? Engineering consultant, the first one. This is the first one, second, third, fourth. These are the work packages. So engineering consultant, execution, leveling, concrete, and finance. Also I put finance. So engineering consultant is required when you are doing engineering project like canal construction, road construction, dam construction, reservoir, town planning, any other infrastructure. So mechanical, electrical. So you need a engineering consultant. And then we, on the basis of this work breakdown structure, we gotta do schedule, budget, performing, and then we close the project. This is here is what I have calculated. Engineering consultant is 30,000. Excavation is $643,000. Leveling is 30500. Concrete is 300,700. And management cost is 50,000 and contingency is 128,574. This is 10%. So plan value and budgeted completion is 12,857, 1.28 million. CBC cumulative budgeted cost, activities, earned value, and actual cost. In the last lecture, I did calculate. CPI is a cost performance index. Very good. So earned value divided by actual cost, and cost variance is earned value minus plan value. So this is the budget. Sorry. So here is the calculation little bit. The calculation is we're gonna calculate the activities along with the project manager and team member and all the experts. So what I did, engineering consultant, they do survey for the canal, they prepare the map, and they give us the material specification, and they check the strength of the material like sand, gravel, and cement. So how much it costs is 30,000. 30030. So per meter we cost $5 on consultancy. This is important in engineering project or any other project, but usually engineering project. So here is excavation. So what we do dig, we excavate, dump. These are the three in this package. These are the three activities. So I calculated 551 cubic feet. It cost $100. So it's actually this cubic feet. When the hydraulic excavator excavate this cubic feet, it cost $100. So how much will be the total measurement? Total cubic feet of the canal is 3306240. 3.3 million cubic feet. So when this cubic feet cost $100, so how much? So you can you divide this, and you got this 600.43. This is the ratio, cubic feet finish, and its ratio. So when you multiply this with 100, so it can give you this one, 600 $45,043, $43.5. So this is the cost how you can calculate. And this is the like if 100 this 551 cubic feet cost $100, so how much will be the other one? So you can divide 100 divided by 2 551, so you got this one 0.19 cent per cubic feet. And when you multiply this with the cubic feet, so you also got this price. So that's how you can calculate the activities in engineering or other project, but you need an expert engineer or some expert person. And for the leveling, I did calculate this and conclude. So total budget is engineering consultant 30,000 and 600,000, 300, 5,000, 300,000, 700. So plus 50,000. So total is $1.28 million plus contingency is 10%. So the total budget is this one. So this is just for example. If you want to calculate the activity, so you just calculate the cubic feet, because we're gonna excavate this to do the canal, and then we level it and clean it, and then we do the foundation, and then we do the concrete. That will be the final product of the customer. This is the schedule. Engineering consultants, it will take 30 days. This will be 34 days, and this will also be 30 days. This is the leveling, and this is the concrete, so it will also 25 days. So when you calculate all these, so this goes to schedule plus 32 days. So it will approximately take 5.5 months. Let's say 6 months. So this is how you can calculate and you're gonna put some extra days in this. So this is schedule. And the last one, which I want to share with you, this is called project charter. So project charter is this is a paper. After this, when we sign it, the project manager and the customer, so the project is officially started. So this is the project name to construct 6-kilometer irrigation canal in Northern Ontario. Future benefit to irrigate 10,000 hectare land plus use for flood control. Scope, all the work done. You gonna put WBS, engineering consultant, excavation, leveling, concrete. This is also required, and then you put the schedule 6 months. So it will start from 1st August 2024 2025. The budget, total budget is this one, $1.4 million, risk, rain and supplier. So this is usually you put, but here is you can put the risk response plan. You gonna make someone responsible for risk response plan. So usually to lower the risk, to mitigate it, or to accept it. So this is nature, you gonna accept it. Supplier, you gonna change it to other suppliers, or that's you need a risk response plan here, but you gonna mention this in project charter. Quality control plan, assure control, you need a matrix here. And sometimes it's like basically the code standard, like ISO 90001 for the material and for the end product. Six Sigma, it's 1 in million. So one error in million. So that's another quality control. It's also and as assume that the weather will be remain same constant. So legal thing, you can put any legal thing if both are project manager, company, and the customer want. So, and you can also put the fixed price contract or cost incentive, cost plus incentive contract or so it's like two type, and then it's further divided to four types. So this is I want to share with you. This is called project charter. This is again this is the project life cycle. Keep this in mind that we start from here and then we close it. So that's the project for cycle. That's what we monitor, and that's the definition. So I hope you got the idea, and thank you guys, and have a nice day. Subscribe to the channel Engineering. Thank you guys. Bye.